I grabbed pizza in case there wouldn't be any by the time this is over. Mathematics and statistics have been good to me. Had a super career. Lots of stories, lots of memories. College professors are building up stories, maybe special papers they've had published, interactions with students. Lots of stories. And somebody told me one time, because I like to tell these stories, there are enough stories you ought to write a book. So I'll go ahead and tell you about it before I get into the good stuff. I did write a book. The title is Random Tales. If you're in math, random tales. Random Tales of a College Math Professor, over easy on Rye. Rye is W-R-Y, because it's my humor and a lot of the stories are a little wacky. One of the things I enjoy in applying statistics and mathematics in some of these stories is there are some funny things that happen when you're not in a textbook. I'll talk about that in a bit. I also, like now I'm retired now, I taught Dean Williams over here long ago. But now I'm retired and I like to read. I read mysteries and I've read enough that I can write a mystery. So what do you write a mystery about? Something you know. So I wrote one called The Death of the Professor. And it's about a statistics professor who dies a suspicious death. It gets investigated. It's not a personal story. But if you're in higher ed, you can come up with a plot line. Okay, so what about these stories? I had 3 hobbies that the college didn't fuss much about letting me have. One was I worked with some local manufacturers in a consulting way. If you're a manufacturer, you may have an assembly line. You take what you've just made occasionally, you sample things that are on the assembly line, you go collect data, and then you look at the data to help you see if something may have changed in your manufacturing process. So there's this area of statistics called statistical process control. It gives you the tools for how to put together mean, standard deviations, and how to tell when something may have gone wrong. Because manufacturers want a consistent product, they want repeat customers, they don't want a lot of customer claims. And so I wrote a book on that. First book, complete course in a quick course in statistical process control, Pearson Press Hall. And I'm old enough now, it's out of print. Okay. I got a lot of stories out of that. The second thing was I refereed high school and college wrestling. I even once refereed a Clemson wrestler at a tournament one time back when you guys had wrestling. And you might think, okay, what does statistics have to do with wrestling? And if I've got time to work this in, a lot of time, I'll tell you, but it doesn't have anything to do with expert witnessing. It was the third hobby, expert witnessing, that I'm going to talk about. When a lawyer needs to try to make a statistical case, the lawyer will probably contact at the university or college, a dean, a math department head, a stat department head, or somebody he knows who works there, and say, do you know anybody who could help me make a statistical case? And that's how I got my first case. At the Medical University of South Carolina, MUSC, there was a student, fellow students turned him in for having, they say, cheated on 4 multiple choice exams. On this exam, he cheated off so-and-so. On the second exam, he cheated off this so-and-so. 4 exams like that. And they went to what was then the Department of Biometry at MUSC. They went to a friend of mine, Boyd Lodehold, and said, can you make a statistical case? What's the probability you would get, if you take 2 answer keys, A is accused of copying off B, what's the probability you could get this extent of agreement or more if no copying occurred? Okay, well, the student had to go before an honor board made up of students. It was supervised by a physician, and the physician went to Boyd, can you make a case? And the student felt threatened, so he went to a lawyer, and the lawyer's sister knew me. So okay. I went down to meet the lawyer. I wanted to meet the student. And when I did, I wanted to get a read on him. He said, I didn't cheat. He didn't hint. I got no readings that he might have cheated. I didn't detect. He could have made a great spy. He had a straight face. I didn't cheat. All of that. And I don't know if he did or not. But I met him. I met the lawyer. The lawyer gave me a copy of Boyd's analysis. And Boyd had put together a method for measuring the extent of agreement. So you have 2 answer keys. A is accused of copying off B. He created what he called an index of agreement. Every question on the multiple choice test has an input to this index of agreement. If on a particular question the answers do not match, which is an indication no copying occurred on that question, the input is 0. Right? If the answers on a given question match, and it doesn't make any difference if it's a correct or incorrect answer, if the answers match, then the input for that question is a number between 0 and 1 that's closer to 1, the more rarely that answer is given. Basically, it's 1 minus the percentage of students who gave that answer. So if everybody gives that answer, the contribution to that question is 1 minus 1, or 0. The most extreme thing at the other end would be you're the only 2 people who give that answer, then the input for that question is close to 1. You add up all the inputs to get the index of agreement. So when you get a big index of agreement, well, if lots of answers match, particularly rarely given answers, if they match. And then there's the issue of how big does an index of agreement have to be before you say, ooh, that's significant, or before it raises a red flag. And Boyd came up with a central limit theorem type of approach to estimate the p-value, the probability you get this extent of agreement or more if no copying occurred. And I like what Boyd did. I thought it was pretty slick. But I wanted to get a p-value in a slightly different way. I wanted to get a non-parametric approach to a p-value. And then I thought, maybe I better clear this with the lawyer. Because Boyd came up with a small p-value, but hey, I might come up with a smaller p-value, which is more damning to the client. Maybe I better clear this with the attorney. So I went to the attorney, told him what I wanted to do, said I could come up with something that hurts his client more than the other side. And he said, oh, that's okay. He says, that's fine. Because if you come up with a different answer, even if it's worse for my client, then I can say, hey, your stat person is supposed to know what he's doing. My guy is supposed to know what he's doing. They don't even agree on what the right answer is. So what's the point of using statistics at all? Okay. So that was his approach. And so I did that. I came up with a different p-value, and I don't remember anymore which one was worse. But think small probability, like 1 chance in a million, maybe he got, and I had 2 chances in a million, something like that. And the student was not kicked out by the honor board. But they did make the student take all the coursework again. That was case 1. There were other cases. I'm going to skip ahead to another case that happened back at MUSC. This was a few years later, when it's no longer the Department of Biometry, it's the Department of Biostatistics and Epidemiology. This time, there's a test that all med students had to take at the end of the first year. And Proctor thought she saw this one particular student copying off another student. So you've got these 2 answer keys. But instead of going to somebody in-house in biostatistics and epidemiology, they sent the 2 exams out to a company that analyzes data. You give them the data, they analyze it, you pay them. And they came up with a probability of 0.001 for a p-value. Probability 2 answer keys would agree to this extent or more, multiple choice if no copying occurred. And my job was not to come up with my own probability. It was to critique what the company did. Didn't have a whole lot of time, so critique what the company did. So I got to go, I read what they did. And then I got in to talk to this honor board made up of med students and the faculty and advisor physician was sitting there. And I was asked, if you were going to measure the probability, what would you do? So I told them there wasn't time to do all that. And then I got to critique the company, and the company had made one error. You could tell they made an error in the report. But they told me as soon as I walked in, don't talk to us about that. We know they made a mistake. We already knew that. Okay. So I found a smaller error, not big time. And then I told them a third thing that troubled me. The ASA, American Statistical Association, has a set of ethical guidelines. One of which said if you're doing work like that for a company, you need to provide enough information to have your work be able to check somebody's work. And the company said that, well, how we came up with 0.001 is proprietary. We're not going to tell you how we got it. And I said, that bothered me. I said, it kind of reminded me of being on the Starship Enterprise. I said, you're on the Enterprise, somebody asks Spock, what's the probability the Klingons will attack in the next half hour? And when Spock immediately says 0.962834913, everybody's supposed to go, oh, okay. All right. Now, I don't know if the student copied or not, but the student was found not guilty. That was another case. And then one other case, which this may be maybe getting tired of hearing about multiple choices, but there was a case at the College of Charleston. There was a student who was failing miserably on all the exams till he got to the final. And he sat next to the brightest student in class, and all of a sudden came off looking like a genius. The Spanish professor looked at the multiple choice exams. Boy, this is a big agreement here on these answer keys. So she went to the vice president for student affairs. I taught him, so he remembers George Haverack. George came to me and said, can you make a statistical case? And so I looked at the answer keys and I applied a technique. I came up with a very small probability. And I wrote a report up. And several days before the students would have their hearing on the honor board, again, at the College of Charleston is also made up of students, the honor board. So they would have a chance to read it. And at the college, the practice then was to let the accused student have a faculty advisor. The faculty advisor was a good friend of mine who happened to teach statistics, but in a different department, not in the math department. And so when I got in, he grilled me about my technique. Figured I held my own, but not an advisor. He became more of a solicitor, an attorney. So he was grilling me kind of mercilessly. I thought that I held my own. Then when I was done with that, he came to me and he says, "Here are two other answers." He says, these two answer keys are very similar to the keys you analyzed. Rarely given answers, given similar, all kinds of answers, a lot of similarities. Would it surprise you if I told you if you did a test on these, that you would come to an opposite conclusion? And I said, well, I can't tell. I mean, I'd have to look at it to make a judgment. Okay. The way you phrase it, would it surprise you if I told you? Yeah, okay. So in the end, what the students on the honor board heard were two professors who both taught statistics, who presented opposite conclusions to similar data sets. They found the student not guilty. I was hacked off. The professor, Spanish professor, was hacked off. Okay. I took the two answer keys that he gave me home and I looked at them that night. Nothing he said about them was true. Nothing. So he had a little girl, he and his wife. We had a little boy. They were in preschool and grade school together. And so the Saturday that followed, they were both at a classmate's birthday party, and I went to pick up our son, and about the same time, he arrived to pick up his daughter. And when he arrived, I confronted him. I said, I looked over these answer keys you gave me. Nothing you said about these answer keys is true. And he said, and I quote, I knew that, but I also knew you couldn't tell that just sitting there. You would have to take time to look at it, which you couldn't do there. And I said, but you lied about the outcome of the test. No, I didn't lie. I made no statement about what a test would show. He says, remember how I phrased it? Made no claim. I said, would you be surprised if I told you that this conclusion may be true? So he didn't make it. Okay, so he and his wife and my wife and I didn't live too far from another. We had been good friends. We went out to dinner a lot. But after that honor board case, we never went out to dinner again. So I ended a friendship based on that case. I had one other case I won't talk a whole heck of a lot about that involved ETS, Education Testing Service. They make exams, SAT, PSAT, bus school admissions test, GRE, that sort of thing. And there was a woman who had taken the exam 3 times. The exam, the national teacher exam. They don't make it anymore, but they used to make an exam called the national teacher exam. And the state of South Carolina decided, you know, it would enhance the credentials of our teachers in the public schools if they all had to pass this exam. So if you're an undergrad wanting to become a teacher, passing the NTE will be a requirement to get certified, part of the certification requirement. If you're already a teacher, we'll give you 3 years to pass. Can't pass in 3 years, you can't teach in public schools anymore. And so she had failed the exam 3 times. Didn't come close. And then she came off looking like a genius. Had she wanted to look like a genius, she should have done it on the first go. Because ETS studies data. They have masses of data. When you retake an exam, they know what kind of swing to expect from one score to the next. And they use statistics to set off red flags. And again, nobody'd seen her copy. It was just 3 terrible scores and then boom. Okay. And she got a letter from ETS. When you sign up to take these exams, there are rules most people never hear about or think about. You sign up for. She gets a letter that says, "We question your score." They didn't accuse her cheating. We question your score. Gave her several options. She could not respond to the letter. I think they gave her a month. They would cancel her score. They had one on there, well, they can retake the exam. And if all by yourself, you can come within 50 points of the score you got last time, we'll let you keep the score you got last time. That'll be the end. The other stuff was legal. She could sue ETS. And for some reason, I got a call that I wouldn't be needed anymore on that case, but I thought that was interesting what ETS does with data. After the cheating case, now this expert witnessing stuff is kind of cool. So with the okay of the department head, I sent a letter out to every lawyer in Charleston. Boy, there were a lot of them. It had a flyer that said, "Need to make a case? Give me a call." And I got some responses. The first call I got was an age discrimination suit. There was a manufacturer that needed to downsize because of monetary issues, going through hard times. So there was an assembly line. People worked on an assembly line, and they terminated 9 of those people. Terminated is highfalutin word for fired. Okay. The youngest of the 9 was 60 years old. So we have an age discrimination suit. And the company, when the suit was brought, said, "Oh, age has no statistical connection." We looked at job performance. We looked at their job performance numbers, and then looked at the numbers, and we could rank them from you're the best, you're the second best, yada yada. We fired the 9 worst performers, and age has no statistical connection. But the people who worked on the assembly line said, no, it's not quite the case. When you start out on the assembly line, you start young too. You're not very good at the job. With experience, you tend to improve. But then if you stay on long enough, at some point, after a certain age, your skill at the job tends to decline. And so I thought, well, I need to see if what the workers say can be backed up, and I needed to create a statistical test based on ranks, best employee, second best, yada yada. The ranks go up, the ranks come down with age on the horizontal axis. I wanted to come up with a test. There are rules of statistical tests, but at that time, I didn't know one based on ranks that fit that. And so I'll come up with one, and I did. And I was not very happy with it. I needed to have a test statistic that was sensitive to increasing ranks and followed by decreasing ranks as age decreased. And I came up with something, basically the test statistic needs to be sensitive to the up down. I wasn't happy with it, but I went with it. And it's kind of nice that they never were too interested in that. The lawyers at the deposition were not too, they were interested in something else I'd done, which I will tell you in a minute. But the up-down thing, where's the peak? Where's the peak gonna be? That gnawed at me for several years. And then I had a sabbatical at Penn State. And I met a guy in the department named Tom Hettensberger. Tom was a master of non-parametric statistics. So we were shooting the breeze one day. I told him about the test I'd done, what I was trying to achieve, and why I was concerned with the statistics and that I had done. And he said, well, what you did makes sense, but I also see why you're concerned. Okay, it's the end of that conversation. But a couple of weeks later, he comes down to my office with the latest issue of JASA, Journal of the American Statistical Association. And in it is an article by Mack and Wolf, Doug Wolf, I don't remember Mack's first name, big names in non-parametric statistics. And they had come up with a test for the up-down thing. Tom said, I didn't read it, but you might want to read this in case it ever comes up again. Here's a test you can use. They come up. So I took the article, I read it that night, I read it the next day, and I saw a flaw, big flaw. They too had to factor into their test statistic where they thought there might be a peak if there was really a peak there. And in fact, they introduced the term, they coined the term, the article title said like a test for umbrella alternatives. The ranks go up, the ranks go down. Test for umbrella alternatives. And so if there is an umbrella, where do you think the peak might be? They had to build that into their test statistic, and that's where I saw the issue. So I can come up with a data set that will make this flaw obvious. And I did. Imagine age, say age, a variable like age on the horizontal axis, and then you're ranking job performance or something. Maybe on a continuum, but you can always then get from the continuum go to ranks. And maybe there's an upward tendency and then a downward tendency. Maybe they just roam around and it's not there. And so I had this data set, and if you applied their test, you would resoundingly reject H0. In other words, you would conclude there's evidence there supporting the existence of an umbrella. And then I designed the data set, so I knew where to go. I went back to one point, imagine this plot of points. And I changed the y coordinate an itty bitty bit, like in the third decimal place. But it changed the rank big time, which resulted in a huge shift in where it thought the peak might be. And if you applied their test now, instead of resoundingly rejecting H0, you resoundingly fail to reject H0. So I went down to Tom's office, Hettensberger, and I showed him their test statistic. Showed him what made it tick. I showed him my example, which is like a butterfly effect. An itty bitty change in the data begets a 180-degree swing in the test conclusion. I showed him that, and his eyes got a little big. And he said, we can beat their test. Oh. Now, why am I giving you all these little memories of mine about this case? Well, because that lawsuit was brought, a new statistical test was created. The Hettensberger Norton test for patterned alternatives. My name is on the statistical test. Okay. And it's a test for patterned alternatives. You want to test for umbrellas, you can set it up to test for umbrellas. Set for zigzag, you want to test for that, you can test for that. Okay. But again, back to the lawsuit, They didn't want to ask me much about what I had done in the 3 days I had to come up with. So I did a test. They think. They asked me about a little example I did. Now remember the group. They fired 9 people on the assembly line. There were 144 people who worked on this assembly line. They fired 9. Only 15 of those 144 were 60 or over. And the company said, age has no statistical connection to job performance. None whatsoever. So I said, okay, get 144 marbles, put them in a bucket. Suppose 15 of the marbles are red. All the rest of the marbles are green. Shake the bucket to mix the marbles. Close your eyes, reach in, draw 9 marbles. What's the probability all 9 marbles are red? And before you get your calculators out, I will tell you it's 8.8 times 10 to the minus 11. Very small probability. That they grilled me on in the deposition because the probability hurt the case so much, small probability. And I have used that example, well, why? A first course in probability and statistics. Maybe the student doesn't hear the term hypergeometric distribution, but they learn how to compute that probability in the first course. So I've used that so many times. And then 8.8 times 10 to the minus 11, that is small. That's just a memory of mine that stands out. Let's see. What the heck about that? There was a manufacturer that called me from Tennessee. How in the heck did you find out about me? But they called and they had a race discrimination suit. The issue was promoting minority employees. There was an allegation that minority employees weren't getting fair shake in the promotion process. So they sent me the data. And I tried everything I could think of to catch them doing something sinister to minorities. And I came up empty, couldn't find anything. In fact, the data were too good. Let's say assembly line workers. Suppose 22% of the assembly line workers are minority. If you looked at the assembly line workers that got promoted, about 22% of them were minority. If you went to some other natural grouping of employees, and maybe 45% of them were minority, and you looked at those folks and who got promoted, well, almost exactly 45% of them were minority. There wasn't even routine fluctuation, okay? So it was pretty clear to me, and it happened across all job categories. It was pretty clear to me they were factoring race into their decision-making process and doing it in such a way as to provide a defense in case somebody sued. Okay, so that was an interesting thing. So one time I worked for a company. I was approached by an attorney in South Carolina somewhere who said minorities aren't making it onto juries fairly. This was a community that was about 33% minority. And I had this fascinating conversation with this attorney, and I'm just going to read it. That's what Taylor is actually in here, the end of Taylor's book. The problem, the attorney maintained, is that on many juries of 12 people, there are less than 4 blacks on the jury. I'm quoting, less than 4. So I asked her about the process for selecting jurors from the pool. Once she explained the process mechanics, it became clear that every member of the jury pool had the same chance of being chosen to be on the jury. So I said, the process you just described is a fair one. She said, yes, but many 12-person juries have less than 4 minorities. Okay, I said, but there will also be juries with more than 4. True, she said, but what about juries with 3 or 2 or 1 or even none? That's just not right, she said. And I responded, the process you described selects jurors at random. The average outcome is 4 minorities per jury. Many juries will have exactly 4. Some will have more, some will have less. That's a consequence of being random. To my way of thinking, she said, the ideal process would have the average be 4, but still make sure that at least 4 are on every jury. I expected more smiles than that. So I said, the only way to have the average be 4 and guarantee that at least 4 would be on every jury would be to impose a rule that every jury had to have exactly 4 on it. Then the process wouldn't be random. And I well remember the look on her face, which said I had just said something she didn't want to hear. So it's time to bow out. So I said, I'm really busy right now. I don't know that I really need to be taking on. So she had to read between the lines, but that was not a case. It all worked out. It's not a case that I got involved in. Another case I won't talk about for time, that's so I can get wrestling in the end, if I can. Discrimination suits were exciting at first. I thought I was doing good, but I quit doing them for a couple of reasons. One, age, race, sex, whatever. How often it boiled down to a marbles in a bucket thing, which was thrilling at first, but got a little stale. Okay. And the other thing was, some of the attorneys did some things that just didn't set well with me. I'm not trying to badmouth attorneys. They're probably doing what they're supposed to be doing. But just didn't sit well with me, so I quit doing those kinds of cases. I got involved as a court-appointed expert in Medicare overpayment cases. When a healthcare provider supplies medical equipment or does something that Medicare should pay for, they'll submit a claim to Medicare. And Medicare just pays. They don't look very carefully to see if they ought to pay it. They just pay it. But then, after a number of cases, they'll do an audit of the company. Now, this company provided motorized wheelchairs to people. At that time, they went for $4,500 a pop, more or less. And after the company billed Medicare for 188 of these things, Medicare did an audit. They sampled 50 of 188 cases and decided that in 46 of the 50, they should not have paid. 92%. By the way, they had a fraud case going on against this healthcare provider. They wanted money back, Medicare. Okay, so what do they want? How much do they want back? Well, for the 46 wheelchairs in the sample, they know they want that money back. But then you have the cases they didn't sample, and they're not going to go sample those to investigate. Now, what could they do? Well, they could say, well, 92% we got from the sample, we'll take 92% of the cases we didn't sample, but sampling error, I mean, there's a good chance that the 92% is too big a percentage to use. So Medicare might be wanting more money back than they ought to get. So they ask for, they take a smaller percent, whatever percentage they get from the sample, like in this case, 92%, they take a smaller percentage of the unsampled cases. So when you total all the money that Medicare wants back, about 95% of the time, they'll be asking back for less than what they're really owed. And taking a conservative estimate helps them win cases. Okay. So I have to testify, but the case is in Florida and I can testify over the phone. So I'm on the phone. It's my turn. I get to talk. Court-appointed expert. What my job was to look at what Medicare did to determine the overpayment and then say whether I thought it was statistically defensible. Okay. So I'm on the phone. The judge says, raise your right hand. How are they gonna know? Okay, but I will tell you, I did raise my right hand, I promised to tell the truth, all that stuff. So I explained what Medicare did, the judge got it. And the other side had its own statistics expert, who I will refer to as Dr. Chuck Dirt. Dirt would say that the most bizarre things. I would describe something and then he would try to say why you can't do that. He badmouthed simulation. I determined some things with simulation. I did a number of things. And then he was very critical of the sample size. Oh man, 50 for a sample size, that's a big sample size. There's a formula for samples, and he cited this formula, and stat students have probably seen a number of different formulas, and the formula he picked was for the wrong setting. And then he said, well, 50, man, what if 50 is too big a sample size? He actually said that. He actually said that. And so I explained, once you figure out what a sample size ought to be, there's never a statistical downside to using a sample size that's bigger than that. There's no harm that can come. And he was just raising the most ridiculous things that after a while, even the judge was not having any of this guy. So after I was done on the phone and hung up, I'm going to call Don Edwards. Don Edwards, Stat Department, University of South Carolina. And I knew that he had expert witnessed in a number of these cases. In fact, I came to find out that Don devised the method that Medicare uses to determine the amount of the overpayment. So I called him up and I told him that this opposing, I told him all the crazy stuff this guy said. And the sample size is too big. I mean, it was just nutty. And after I was done, Don said to me, was his name Chuck Dirt? And I said, yes. He said, I've been trying to get him disqualified being an expert for years to no avail. So I got to meet Chuck Dirt. Well, over the phone. Let's see. And then I think I'm gonna have time. When do you want me to stop? 10 till? Like 50 minutes? Was that the deal?
Yeah, what you mean?
Okay. The last expert witnessing case was actually geometry involved. There was a homicide in Charleston. And the police were trying to figure out, was it a suicide or a homicide? Woman was found dead on a bed. She'd been shot in the head. You want to imagine she's lying on her back, kind of like this, looking at the ceiling. Bullet went in the right side of her head, exited the left, landed on a pillow. Here's the pillow. And it left a scorch mark, blood streak, a line segment about this long, and then the bullet was at the end of the line segment. And so they came to the math department, went to go lightly, the department head sent me homicide or suicide. And let's see, there was a revolver. She was at this, as you're at the foot of the bed, looking at the bed, she's on the left side of the bed. And below her hand on the floor is a revolver. Okay, so you got the bullet here, the revolver there. She's laying on the back. And could she have committed suicide, or did her boyfriend do it? Now, her boyfriend was a bad actor. They told me about him. He had a very long rap sheet. In fact, the lieutenant in charge of the case told me he had a habit of forcing people to play Russian roulette. Okay, he was a bad guy. And she was going to leave him to run off with a sailor. That was back when Charleston had a naval base. But before that could happen, she winds up dead. So in my office, they brought oodles of photographs, every kind of photograph of the scene that you could imagine. And I was able to single out one photograph where I could measure an angle. These are the days before CSI and software. I got out a protractor. And so here's the end of the mattress. Here's her head. Here's the line segment. And I could measure the angle between the end of the mattress and the extension of the scorch mark blood streak. I could measure that angle. And so I asked the lieutenant, would going through her head bend the path of the bullet? And he says, the way it did, not enough to worry about. So we're going to assume a straight line for the bullet from revolver to pillow. They determined, there was that. She was real drunk. Well, yeah, I've told you now. She was very drunk at the time the bullet went through her head. Another thing I will tell you now is that she was left-handed. And the bullet went over here. She was left-handed. There were scorch marks on, not scorch marks, shot residue on both of her hands. Okay, on both of her hands. Could this very drunk left-handed woman have taken the revolver in both hands, pushed the trigger with a thumb, sitting on the bed, committed suicide? Okay, so we're going to assume a straight path. And then I made an observation. It seems to me when the bullet hits the pillow, hitting the pillow isn't going to cause the bullet to veer left or right. The thing is going to keep trying to go straight. And the police there, yeah. Okay then. I don't think I can give you the exact path of the bullet, but I think I can give you the vertical plane that contains the path of the bullet. And that line segment lies in the plane. So here's this line segment. The bullet could come down at a shallow angle or a steeper angle, but here's this vertical plane containing this line segment. And they got that, said, aha, can you come Saturday morning and do a crime scene reconstruction? So we go to a local hotel that's cooperating with the police. They had a bed there, a number of police there. One was a police woman, approximate size of the victim. And they had brought crime scene reconstruction stuff. They had a styrofoam mannequin's head with a rod through it. And the rod showed the entry and exit points. They had made what looked like a cat scratching post out of 2x4s, except it was about this tall. No carpet out of 2x4. So a platform and then this vertical post. And they had string and all kinds of stuff that they bought. So I brought my protractor with the string taut across the pillow. We recreated the blood streak the line segment. And then with that string long enough to go to this edge of the bed, they scooted the cat scratching post over till it contacted the string. Okay, so the string against the post, and then, oh, and I had them take the rod out of the head and replace it with string. Okay, so they take one end of the string to the beginning of the scorch mark. And then they held the string against the post, and you got this mannequin's head sitting on the string. And then the first thing I said was, well, maybe she was sitting on the bed. Could she sit on the bed, do what I described with both hands, and fall back to where the picture shows she landed? And of course, when you move the mannequin's head to be perfectly vertical, her body would have been embedded in the mattress. Okay, so that's one potential bullet path down, infinitely many to go. So they tried holding the string against the post in various places, and we ruled out almost everything except this little window on the post where they could hold the string there, straight string. She could sit on the bed, put her head where the mannequin's head was. Okay, and you had play in the mannequin's head. You could rotate it on the string, you could move left or right. But she could put her head where the mannequin's head was and fall back to where pictures showed. Except this narrow window on the post made her sitting position kind of interesting. She would have to have been halfway up into a sit-up. Not all the way up, halfway up. So, if you were left-handed and very drunk, and wanted to commit suicide, would you sit on a bed, hold the gun in both hands to this side of your head, push the trigger with a thumb while halfway up into a sit-up, and oh yeah, looking a little to her left? Okay, that's what the mannequin said was doing. No, that's not what you would do. So the police figured, okay, looking like it wouldn't have been a suicide. But just to dot all the I's, the lieutenant asked me, could I think of any other way that all by herself, she could have shot herself, have the revolver land where it landed, have the bullet land where it landed? Could I think of any other way? Okay, long ago, before the College of Charleston, I was a soldier. Being in the U.S. Army gave me a rather bizarre sense of humor. So when he asked me that, I said, sure. I said, starting at the door, she could have run toward the bed, jumped up in the air to do a Fosbury flop onto the bed. And just before she lands on her back, when her head gets where the mannequin's head was, she shoots herself in midair. The police lieutenant was not very humorous. He looked at me and he says, that's ridiculous. And I said, yeah, absolutely. I said, the only scenario that makes sense is she was sitting on the bed in the way we determined. So they were now convinced there was no way it would have been a suicide. Nobody could argue it could have been a suicide. So they went for a homicide investigation. Ultimately, the boyfriend was convicted. There were people who gave him alibis, but once they were on the stand and under oath, they changed the tune. So he got convicted. Now that's the last expert witnessing story. And I can stop there because I think you mentioned in the letter 15 minutes, 50 minutes. I can also talk a little bit about how wrestling tied to statistics. But I can stop. I'm happy to stop. Whatever you want to do, Jim.
I would say you go ahead and we won't take any pot shot at anybody that's got to leave. How about that?
Fair enough. Fair enough. Long ago, I used to referee high school and college. And in the mid 1980s, there was a practice. And I don't know who started this, what state it started, it was just kind of bizarre. You know, wrestling has weight classes. Most wrestlers try to stay at the top end of their weight class. But if they're overweight, come the weigh-in. You gotta do a weigh-in before a tournament or a meet. If you're overweight, you're not gonna wrestle in that weight class. So they're very careful about watching their weight. And, but in almost every tournament, there would be somebody, take a typical old-time doctor's room scale. You step on the platform and you have this thing that slides across a bar that's got notches in it. And then you have this little slide on a kind of a continuous basis that's on this arm that goes through a little rectangular window on the frame. And if you're way the heck overweight, when you set the maximum weight that somebody can be in and they step on the scale, if they're way overweight, the bar is gonna go boom to the top of that window, you're overweight. If there's clearance between the arm and the top of the frame, they've made weight, they're fine, they can wrestle in that weight class. But sometimes there would be somebody in the tournament where the thing would come up and touch. Not bang and touch, just come up and barely touch. So typically they try to run and lose weight, sweat off weight. So, but what do you do when you're just touching and you got about 2 minutes left to make weight, or you don't wrestle? And so what referees saw people doing is they would do a headstand. They'd stand on their head for a minute, maybe 2 minutes. Get back on their feet, and there would be clearance between the bar and here. Okay, you've made weight. Every referee saw this. Every referee saw it. But you would tell somebody who wasn't in wrestling, that's nuts. Mass doesn't go away. Why would that ever happen? Anybody here wrestle in high school? You ever hear that?
No.
Okay, that's true, because when I retired, I'd ask students, they'd never heard of it either. But they actually put in the rules one time, they'd forbidden that. Headstands during weigh-ins, high school, college, international, okay. But nobody does it anymore, so most people haven't even heard of it. And so I thought nobody ever quantified this, but every referee has seen it. So I worked with a couple of high school coaches. I knew all the high school coaches. And I went to their practices. And of course, all this weight loss would take place after they'd been running, trying to lose weight. Well, at the beginning of every practice, you run, you do all kinds of things to lose weight. So I went to these practices, and then I'd have a scale there. They would step on the scale. Now, the kind of scale I just described is not designed to measure, to quantify small amounts of weight. I mean, we think of people who measure weight to the nearest pound. But what I did, and I went to the physics department, I went to a guy and said, you got any gram weights I can use? Oh, we don't use gram weights. Get yourself some paper clips, big legal paper clips. I got a box of paper clips. And I would take 10 of them and take 9 of them and a 10th one and wrap them in a bundle. Okay, so I had these 10 paper clip weights. And so I'd weigh somebody after they'd been exercising before. Well, I'd weigh them. And then I took some Post-it notes. I cut these little pointed arrows with the sticky parts of Post-it notes. And I put one on the arm that goes up and down. And then when I'd weigh the student, I would put the other Post-it note on the bar frame. So the points of the 2 yellow Post-it note arrows pointed together. So I had the students weigh. And then I had a couple of methods I looked at. One was this wrestler does a headstand for, I think it was 1 minute and 45 seconds. They'd step back on the scale, and there would be this the scale arm would be a tad below, almost all. So I'd start throwing paper clips onto the scale, and you could watch the scale arm rise, okay? And when I got pretty close to getting the arrows to point together, I quit throwing on 10 clip bundles and I threw on single pin paper clips until the arrows aligned. And so I recorded all that. And then for the same wrestler, I also had a second method where they would just stand there doing nothing, not a headstand. So I compared the headstand versus the non-headstand. And then the issue is, how accurate is the scaling on this? So I had people, I measure the weight, get the arrows to point to one another, have them step off, do nothing, and then right away step back on. And the arrows might not point exactly to one another anymore, but 3 paper clips either way would realign them. So whatever error there was on a typical doctor's scale, if the scale was accredited, it has to be accredited every year, or it can't be used. You had a 3 paper clip plus or minus error that I took as standard, and people were losing 30 paper clips, 40 paper clips, or 20 paper clips. So I boiled down to the average weight, and you tell this to people who aren't in the wrestling community, they go, this is nuts. This is nuts. But the average weight loss was about 1/20 of a pound for all weight classes. Standard deviation was bigger than 20 pounds, so a lot of difference from individual to individual. And I went to an anatomy professor at MUSC and I said, I think this has got to be blood. When you stand on your head, blood goes to your head more than is usually there. And there are not valves there to keep the blood going the way it ought to be going. Okay, your face can get red. And then when you get back on your feet, the blood drains out. Imagine something that's in midair. This was going on in my head. And I said, like, take a big box like an elevator, put handles on the ceiling of the elevator, jump up, grab onto the handles, weigh the elevator. You get your weight plus the elevators. Then let go and weigh the elevator, but weigh it before you land. Okay. Your mass is still there. It just doesn't show up as weight till it's landed. So I'm imagining falling blood. And she said to me, yeah, falling blood primarily, probably interstitial fluid. I'm not in biology. There are other fluids in there too. But every referee saw this. So it's about 1/20 of a pound. And then Roxy Peck came to a talk I gave on some meeting on this. And she had a bunch of books with DeVore. So there's when they get to regression in one of the DeVore Peck books, she uses this example as an illustration. So it's in an AP stat book. Okay, I'm done. I quit. Anybody got any questions? Anything?
I think that if you were like laying in near a black hole, that would make a huge difference actually, right? Depending on how close you are to the singularity, right? If you got all the blood in your head as opposed to contributing to your body.
I've refereed many tournaments and meets, and to my knowledge, we weren't near one. Could have been, don't know. Okay.
So I have a couple. So is Dr. Dirt?
I'm sorry.
What was Dr. Dirt's history? I don't want you to have to reveal it.
PhD from MIT in economics.
And oh yeah, so the lawyer, the one that was wanted 4 average, but always at least 4.
Yeah. I don't know what happened there. I was done with it. I just excused myself. I have no idea what happened.
I had a friend in physics that went to a meeting with a guy who was obviously a crank, who had built a perpetual motion machine where you could power it up its own thing, and then you had a battery that was being charged with the extra energy or whatever. And my friend said, you know, the guy was an obvious crank. He said that the thing that amazed him was the fact that there were 3 lawyers in the room saying, yeah, can we get this patented? Did you guys have like gen ed physics?
Being good at one thing does not necessarily mean that carries over.
Thanks. Any other questions? Well, let's thank our speakers.
Oh, random tales. College, go to Amazon.
I think